Hello everyone. In this video, I'm going to be going over the 7th lab in CIT 247. So, for the last couple of labs, you've been working with connected routes and static routes. If you recall, there is a third kind of route known as routing protocols. Well, there's a third way to generate routes, known as routing protocols. So basically, instead of configuring a route statically, you configure a protocol on a route on all the routers, and they basically promote their networks to other routers. And it basically helps routers, in a way, automatically populate their routing tables with other routers' subnets. So that is kind of what OSPF does. It's kind of the goal. And for this lab, you're going to be building this topology. You don't need to build the circle necessarily, but it's kind of just there to visualize the router interfaces that are in this subnet. So an important thing you'll need to do in this lab is make sure you use this router. If you don't use this router, this will likely not work. Even more importantly, you need to make sure you use the Ethernet switch. Do not use this 247 one. You really need to use just this Ethernet switch. You will not be configuring it, by the way. It's just going to be there to be a switch and nothing more. There's no switch configurations in this lab, but if you use this one, your OSPF configurations will not work, because this one actually is configured to block OSPF advertisements. So please make sure you use the Ethernet switch and the C2691 router when working or when building your topology. Now you'll next need to configure IP addresses. This will be pretty much the same thing you've been doing throughout this class so far. So you should be able to see this topology here, and following the instructions below, you should be able to easily configure IP addresses on all these interfaces. And then you should be able to do these ping tests pretty easily. The ones that are noted to work should work. And then we get to configuring OSPF. Now, not all these ping tests will work, which is because, the reason that happens is because the routers do not know how to route some of these ping tests, which is where OSPF comes into play. Now, OSPF has a pretty specific way you need to configure it, and I will be demonstrating that here. So I have a test GNS thing I built a previous semester. And I've deleted the OSPF configurations on it, but you can see the let me redo this command here so you can get a better look at that. So you should be able to get a good look at the IP addresses configured on the router interfaces. Ignore this number at the top of the terminal window. The router's real name is right here. So router 1, you can see, has an IP address configured on its serial connection, which is in this subnet. And then it has one configured on its F0/0 subnet, connected to PC2. Router 2 here, right here, has an IP address in this subnet in the Ethernet interface, and it also has an IP address that is also in this serial interface. So, to configure OSPF, the philosophy behind configuring OSPF differs from static routes, where when you're configuring a static route, you're typically you are listing the destination route, the subnet mask of that route, and then either the IP address of this interface that is adjacent to the router you're configuring the route on, or the interface name that leads to the router connected to the destination subnet. Contrasting with this is how OSPF is configured, where you are instead configuring routes or creating advertisements that are set to promote the subnets that are hosted on the router you're configuring. Let me explain, or demonstrate. So conf t. To start configuring OSPF, you type router OSPF and then a process number. We typically just use 1. The process number doesn't matter. Then you configure the routes or the networks. You basically upload the networks connected to this router you're going to promote. And you just start with the word network. You type in the subnet ID of the subnet you're promoting. Let's start with the one in the middle, 0. Now, the second part here uses what's known as a wildcard mask. I believe that it's discussed in your PowerPoint, but basically you need to take the subnet mask of the subnet you're creating an OSPF route for, you need to convert it to dot decimal notation, and then you need to use its wildcard mask. So 0.0.0, oops, not O's, 0.0.0.3. So the wildcard mask, or the subnet mask for this is 255.255.255.252. The way you discover, or the way you calculate the wildcard mask is take the subnet mask and subtract it from all 4 octets having 255. So 255 minus 255 is 0, which is applied to these octets. But the third one, 255 minus 252 equals 3, and that's how you come up with the wildcard mask. And then finally use area, and we just use area 1. And that's the first network. Now we can actually bring this back for convenience. Now we're configuring, oops, let me redo that. Actually, that's correct. Okay, we need to delete that. And what I'm doing here is just getting the other network in here. 2, 0, 10. So this is the private interface, or private network, if you will, for router 1. It's the one where client devices are on. So we got 10.0.2.0. So we have the subnet ID again. Excuse me, subnet ID again. We have the wildcard mask. So this in DDN, or dot decimal notation, is 255.255.254.0. So 255 minus 255 is 0. So the first 2 octets have 0 in the wildcard mask. The third one is 255 minus 254, which is 1, and then 255 minus 0 is 255. And then finally, you need to implement a passive interface. So passive int f0/0. Now let me explain this. The passive interface is an interface that we're not going to allow the router to promote OSPF routes to. The reason we do this is because we want to improve performance. If our router is promoting OSPF advertisements to subnets that do not have a router, it's wasting space. That PC is not going to know what on earth to do with a OSPF advertisement. So it's going to pretty much disregard it. So that's why we're going to set up a passive interface on the Ethernet interface here, so PC2 doesn't get those advertisements. Oops. And there. Now, if you notice here, show IP route. So yeah, you may be wondering, hey, why are there no routes on here? Well, that's because OSPF, when you use OSPF, the routers learn each other's subnets. So just configuring something on this router is not going to bring up any OSPF routes. But if we do show IP protocol, I think is the command. There's our OSPF configurations. I can expand this a little bit. So here are our OSPF configurations. You can do show IP protocol to see the networks you configured, the area they're in. I believe passive interfaces are listed right here, and here's the OSPF process you used. So that's how you can check the OSPF configurations you made on the router you typed them on. But routes instead are going to appear in other routers. So show IP route. I believe there should be routes appearing here. So they won't appear immediately here either because we haven't configured OSPF. So an adjacent router probably is going to use OSPF until OSPF is configured on that router as well. So let's go ahead and do that. So router OSPF1 network 192.168.0.0, the same exact network. We can do 0.0.0.3 area 1, and then network 10.0.0.0. Okay, look at this. Do you see this here? This message on both of them means that the OSPF routers are acknowledging each other and they've become neighbors. So they're sharing routes with one another. So we're going to go ahead and configure the other subnet mask, or the other network, sorry. And then area 1, also configure passive passive int f0/0. End. Show IP route. There we go. Show IP route. So see, now we have the OSP of routes on the router. Now look, router 1 has this private, or this Ethernet subnet that router 2 is connected to, and router 2 has the quote-unquote private subnet, or the 10.0.2.0/23 subnet that is connected to router 1. Now if we did a ping, let me see if I remember how to do this. Let me do this. Show IP int brief. So we should be able to ping 10.0.0.1. Yes, if I'm correct, extended ping is 10.0.2.1. So yes. So this is proof why by doing this extended ping here, where we're pinging this interface here from this interface, starting from this interface, it proves that this subnet can communicate with this one all the way over here. So that's how OSPF works. So we'll scroll down. So you can go ahead and set those passive interfaces up in these commands, and that will take care of this section pretty well. You have a few questions, and you need to provide a ping test and all that. But then you'll be changing a subnet in this network. So this subnet right here, if we scroll down, so the main router, you need to change its IP address to 192.168.0.10. So this one right here. You'll be changing this one because we're changing the subnet mask. If you see the subnet is 192.168.0.0/24, we're going to be changing the subnet to be smaller. So if you see here, you need to find a new subnet mask for this network that minimizes the number of possible hosts. In other words, we're decreasing the size of the subnet. So the subnet mask number here is actually going to be bigger. And I can prove that with this table. If you look up a table, subnet masks reference table is from cloudaccess.net. Very helpful table for this assignment. So currently you have a /24 mask in this network. You see right here, this subnet right here with all these F0/0 interfaces on the routers. This supports up to 254 hosts. Problem is, if you can see here, we don't have 254 hosts there, and that's kind of wasteful. So to decrease the size of the subnet, we can use another mask. Now, I'm not going to tell you which one to use, but I can tell you, well, I'll give you a little hint. So it's not going to be /17 because we want the smallest subnet that could still support 10 hosts. So make sure you pick the right mask in that regard. It's not going to be /27. It supports 30 hosts. That's way more than what we need. And there's still masks that are smaller. There's still a mask that's smaller that could still support it. So then you'll configure all that, and that's pretty much it. You may not necessarily need to update your OSPF configurations, but if you want to, you can take a look and verify them. Your ping test after that, once you configure the interfaces and all that stuff, everything should work just fine. Just be sure to follow the instructions here, and you should be good. Thank you all for watching this video. I hope it's helpful. If you need any help in this lab, please don't hesitate to contact me. Thank you all for watching and have a great day.